This lesson is on entropy and microstates. Microstates is a specific configuration on how a system is distributed. We use the variable W, and Boltzmann determined one can calculate entropy based on the number of microstates using the following equation: S equals K ln W. K is Boltzmann's constant, which is derived by taking the universal gas constant divided by Avogadro's number to get 1.38 times 10 to the minus 23 joules per K. Note, entropy is a thermodynamic function that increases with the number of energetically equivalent ways to arrange the components of a system to achieve a particular state. Simply put, the more microstates there are in the system, the higher the entropy. In the first example, two flasks are separated as macrostates, where each system has one flask containing 4 particles and the other has 0 particles. So how many ways can one get 4 particles in one flask? And as it turns out, there is only one way, as seen here, once the stopcock has opened and volume expanded. In the next example, we have 3 particles in the left flask and 1 particle in the right flask. If we open the stopcock, there are 4 microstates possible to achieve this specific outcome. The third example has 2 particles in each flask when closed, but when open, there are 6 possible microstates to achieve this specific outcome. To calculate the number of ways to achieve a specific outcome by probability methods, it is n exclamation point divided by the product of n minus r in parentheses exclamation point and r exclamation point, where n is the number of particles, r is the number of particles in one flask, and n minus r is the number of particles in the other flask. For example, 10 particles, where you have 5 particles in one flask, results in 252 ways to get 5 particles in each flask. However, if you want to determine the relative number of microstates from a specific number of particles, one can do that by looking at how many particles are present in the closed system. Suppose you have 2 particles in a closed system, and it will represent at least 1 microstate. When you open it, the volume will increase and the number of possible locations equals 2 to the n power, where n is the number of particles. If n equals 2, then W equals 4 microstates. One can calculate delta S, which equals S final minus S initial, which equals K times natural log of the ratio between W final over W initial. If your calculator works when replacing the W ratio with 2 to the n power, then delta S equals K times ln 2 to the n power. Note, if n is too big, then n times K ln 2. For example, if n equals 2, delta S equals 1.91 times 10 to the minus 23 joules per Kelvin.